Okay, here we have a question about magnetic forces. We're being asked to consider a wire, okay, with length, or a rod, sorry, with length L, and it's moving to the right as a result of turning on the current. As ever, press pause and try the question, and when you're ready, press play to see the answer. Okay, so I think I've not really seen a question like this one before. However, it makes sense when I go through it. It's just a little bit different in terms of the setup. So in this case, we've got a cell. Now the cell has deliberately been blocked out, so we don't know the direction of the current. And that's what we're going to try and work out. Now, it says here we've got our conducting wires and a movable rod. And when we turn on the current, this thing moves to the right. It is pushed to the right. We want to know the direction and initial force on the metal rod. Let's think about this just now. We've got a force on the metal rods. This comes from BIL sine theta. Now notice, hopefully you can see here that there is one answer here which must be ruled out straight away, and that is C and D. Why? Well, if we had the initial force BIL sine 0, sine of 0 is 0, and so therefore we would have no force. In other words, the rod would not move. We need the rod to move in this scenario. So BIL sine 0 must be out because it doesn't move the rod. We're then left with BIL sine theta. That makes sense, okay, because we've got right-angled vectors oriented at a right angle. However, we don't know the direction. We don't know if we're going up or down. This is where, again, we need to apply our left-hand rule. And again, I'm sorry you can't see me do this, but right now what I'm doing is I'm looking at the field. I know that the field is pointing out. I also know that the force is to the right. Okay. Now, if the force is to the right, it's quite awkward for me to do this. I'll be honest, I'm sitting in my office trying to point away from myself. Force is to the right. My middle finger is pointing up. Now, if the current is pointing up on the right-hand side, hopefully you can see that it must be following this direction here, which is anti-clockwise, and that's why the answer here is A.